everyone, welcome to Entrance Wise. Myself Swastika from IIT Kharagpur. I am gonna teach you physics for your JEE-NEET exam preparation. So let's start with the chapter of kinematics in 1D motion. In this video, I am gonna discuss on the topics of mechanics and its different classifications. So, mechanics is the branch of physics that deals with the motion of objects and forces that causes this motion. Mechanics can be classified into two main categories, dynamics and statics. Now, statics deals with the objects at rest where forces are balanced. For example, a book resting on a table is in static equilibrium, whereas dynamics studies objects in motion. Dynamics itself can be divided into kinetics and kinematics. So, kinematics focuses on describing motion without considering its causes, like a car moving along a road. Kinetics examines the forces behind that motion, like the engine's power propelling the car. Now, let's discuss about different types of motion. So, there are three types of motion: one-dimensional motion, two-dimensional motion and three-dimensional motion. So, for one-dimensional motion, this is motion along a straight line, like a train moving on a track. For two-dimensional motion, motion in a plane, like a basketball being thrown in an arc. For three-dimensional motion, motion in space, such as a drone flying through air. Finally, let's discuss about some important terminologies such as rest and motion. So, an object is said to be at rest if it does not change its position with the time relative to a reference point. Conversely, it is in motion if it does not change its position relative to that reference point. For example, a car parked in a garage is at rest, but once it starts moving, it's in motion. Now let's start with reference frames. The perspective from which we observe and measure motion. A reference frame can be classified into three types: Cartesian frame of reference, polar frame of reference, spherical frame of reference. Now for Cartesian frame of reference, we use X, Y and sometimes Z axis to describe the position of an object. For example, the position of a point is defined by its coordinates X and Y. Now here, this is for one-dimensional reference frame. For one-dimensional, we can describe it by only X-axis, whereas for two-dimensional, there are two axes, X and Y. For three-dimensional, there are three axes, X, Y and Z. For one-dimensional, there is only one measuring unit. That is, we can say that this system has moved by X units. Whereas for two-dimensional motion, there is a coordinate system. That is X and Y. And we get the position or the distance from the origin by r equal to root of x square plus y square. For three-dimensional, we get it r equal to root of x square plus y square plus z square. Now for polar reference frame. The polar frame uses a radius and a angle to describe a position. Think of it like plotting a point on a circular radar using distance from the center and the angle. Just like this, there is a theta, this is the angle and this is the polar coordinate r comma theta, and we describe it as x equal to r cos theta and y equal to r sin theta. Now we will get tan theta equal to y by x. Now coming to spherical reference frame, we use three values: radius, polar angle and azimuthal angle. This is useful for describing positions in 3D, like the location of a satellite orbiting the Earth. Reference frames can also be classified as inertial and non-inertial frame of reference. For inertial frame of reference, we can define it as one where objects not acted upon by forces remain at rest or in uniform motion. For example, a passenger in a car moving at a constant speed on a straight road experiences an inertial frame. Now, a non-inertial frame is accelerating, causing objects to experience frictious forces. For instance, when a car suddenly brakes, passengers lurch forward due to the non-inertial frame. Now, let's discuss about motion and its classification. So, motion can be classified into translation and rotation. In translational motion, an object moves along a path without rotating. For example, a car driving straight down a highway. In rotational motion, an object spins around an axis. A spinning top or earth rotating on its axis are examples of rotational motion. Now, let's define some key terms: speed, velocity, acceleration. So, what is speed? Speed is the distance an object travels per unit time. That is, speed equal to distance travelled by time taken. There is also average speed. Average speed is the total distance travelled divided by the total time taken. Now, what is instantaneous speed? Instantaneous speed is the speed of an object at a specific moment in time. It's like looking at a speedometer in a car. Like this is very small distance covered by very small amount of time. Now, what is velocity? Velocity is speed with a direction. It's given by velocity equal to displacement by time. Displacement is a vector, where displacement defines the change in position. What is acceleration? Change in velocity with respect to time. So, मिलते हैं अगले वीडियो में. Thank you guys.